My name is John Kowalski. I'm part of the marketing team here at Bitgardner. And today we'll be talking about elements of a corporate communication or a corporate color program. Marketing on my mind. How about that? So anyway, we are recording this, and immediately following the presentation, you'll receive an automated link with this recording. Feel free to watch it later, pass it on to colleagues, whatever you need to do with that. Also, if you have any questions, please log them in the chat function in the bottom right-hand corner of your screen. Time permitting, we'll be able to get to a few of them. If we do run out of time, we'll reach out to you individually to make sure your questions are answered. Today's speaker, we have Ms. Ray Roby. She's our business line manager for automotive, and Greg Schreider's on as well for moral support and color expertise. So with that, Ray, it's all yours.
Good afternoon, everyone. Today we're going to talk about elements of a corporate color program. So in a corporate color program, there's 5 things that are important. There's instrumentation, there's the standards and the organizers, there's software, there's the data share, and there's data analysis. And we're going to talk about all these things today. So first off, we're going to talk about instrumentation and what's important about instrumentation when you're doing a corporate color program. So for this specific presentation, we're talking about multi-angle color and effect measurement. It's important that you have really good inter-instrument agreement or reproducibility and repeatability for short and long-term temperature ranges. So when we look at different qualities of metallic coatings, there's 2 things that can affect how they look. It can be if you're looking at something on a sunny day or if you're looking at it on a cloudy day. So this is our multi-angle instrument. It's called a BICMAC I. It measures color at the -15, the 15, the 25, the 45, the 75, and the 110. It also can characterize your sparkle. And this is direct illumination at the 15, 45, and the 75. And there's a camera in the middle. You can see where it says CCD chip. It's actually the detector that takes the picture. And then graininess is diffused illumination. It's the half circle that you see. And this is the detectors in the same location as for the sparkle. So just to give you an idea of what we're talking about when we talk about sparkle and graininess, sparkle, like I said, is direct illumination under sunny skies, and graininess is diffuse illumination under a cloudy sky. So these are 2 very different appearances, and this helps you quantify what's going on with your color and for your harmony. So when we talk about sparkle, the viewing conditions, if you were looking at it inside, would be like a spotlight. Outside would be the just direct sunlight. The observation angle is very critical because depending on the angle, you're going to see different amounts of sparkle, and maybe even some angles you won't see any sparkle at all. So the sparkle is generated using the reflectivity of the individual effect pigments. So this gives you an idea if you have the same flake in your material, the amount of the effect pigments that are in the material, and also the size. Graininess, this is what we call texture or structure or coarseness. People use different terminologies, or even salt and pepper. These viewing conditions are diffuse illumination. So if you're looking, say, like in a light booth, you're really looking at more at the graininess and not so much at the sparkle, because that would be diffuse illumination. The potential causes for graininess are the flake type or the size. If you have disorientation of the flakes, it's going to cause you to have different looks. So if you spray something wet or you spray something drier, it's going to change your graininess. And then under some severe circumstances, you can get agglomeration of the particles, which is going to make your graininess be higher. So when we did the experiment to figure out how we were going to define this coarseness or this graininess, what we did was we set up a room that had white sides to give you more diffuse illumination. And then we had 8 anchor panels set up that were of different size of coarseness or graininess. And these were all laid out so that you could look at them visually. And we used over 200 colors to do this experiment because we realized that sometimes the color can affect how it looks visually. And here's what I was talking about with those 8 anchor panels. We had over 5 different observers looking at these, and they would take each color of each panel and they would find out where they believed that the graininess was located on this 8 sample set. And they could pick in increments of 0.5, so half of a number. And what we did was also for the glint, the same exact experiment, but this was under direct illumination, and it was at all 3 angles that I told you earlier, the Big Mac measures, the 15, the 45, and the 75. So we took all the data that we got on all these different panels, and we used the glint or the sparkleness for one axis and the diffuse or coarseness or graininess for the other axis, and we found that these 2 different categories are independent of each other. So we couldn't come up with a correlation between that, but we did figure out that almost all of the panels that were looked at, everyone defined them the same as for graininess and for sparkle. So the correlation between the visual assessment and the numeric assessment was 0.91 to 0.96, which is very, very good for a correlation. The absolute difference in diffuse coarseness and glint between an individual observer was about 0.42 to 0.72 units. This is a really good range also because what would we do? We needed to come up with numbers that we could use but have different intensities. So for sparkle, there's 2 things that go into sparkle. One's called the sparkle area. It's not necessarily the size of the individual pigment. It's more the total amount of reflection that you're getting back to the camera. So you could have a sparkle area that is the same on 2 different panels. One could have a low concentration of a large flake, and one could have a small concentration, a large concentration of a small flake, and you could get the same sparkle area. So it's important also to look at the intensity. This tells you kind of what the material is. So if you had a Zerulic in one panel and just a mica in another panel, those 2 panels are going to measure the intensity completely differently. The Zerulic would be much higher. Here's an example of how we set up the tolerancing. The typical tolerancing for sparkle is the 3-to-1, the last one on the right. But you can also change this depending on the materials that you have in your coatings. Some materials that have maybe a bigger flake at a higher concentration, you can have more variation, and it's not going to affect what you see visually. And some other materials may have to have a lower tolerance because they may show up a lot different when you look at them visually. So this just shows you the graininess scale. It goes from 0 to 15, fine to very grainy. For solid colors, the graininess should be 0. We have seen in some cases where if there's dirt on a panel or something like that, it could actually show up as graininess. So why is this important? So we have two panels. One's a dark gray that has a coarse flake, and one's a dark gray that has a fine flake. And when I look at the color numbers from the -15 to the 110, I really don't see a lot of difference in the data. So how am I going to be able to tell that these two colors look different? I need to look at the sparkle on the 15, the 45, and the 75, and also the graininess. So for the dark gray panel that has the coarse flake, my sparkle is 6.9 compared to my fine flake on the sparkle 15, that's only 1.3. So visually, this would be very, very different. And a lot of times what people like to use this for is harmony on the vehicles, because it really tells you if your color looks pretty good, but something's still off, you can look at the sparkle number and figure out what's going on. Also, here the 2.9 to 1.1, that wouldn't be as varied between the two panels, but you'd still have some variation. And the 9.5 to the 6 for the graininess is also pretty big variation. So remember when I talked about it before that most people can see 0.5. So here you have a lot more than 0.5 variation in the two panels. So how can we use these numbers? The graininess, this gives you, I talked about it earlier, the different flake size and the agglomeration of effect pigments if you have that happening. The sparkle 15, this tells you more of the formulation. So if I have two formulas, one from one supplier A and one from supplier B, and there's a variation, it could be something going on with the flake size or the flake itself, the intensity, or the actual material. The Sparkle 75, this one usually has to do with application. So if I spray something wetter or drier, I can change my Sparkle 75. If I use different applicators, I can change my Sparkle 75. And also if I have overspray. Here's just an example of some sparkle data that you get out of our software. So here you can see all of these are pretty much within the tolerancing that we set up for this experiment, but this just shows you what it would look like in the software. And here on the x-axis is actually the sparkle area, and the sparkle intensity is on the y-axis. And at the bottom, if you can see it, there's the graininess numbers that we got off these panels. So this was basically a vehicle that we looked at, and we did it for harmony. So here you can see that there's some examples, like the 45 angle, that is a little bit more separated. So you could potentially see some differences with that. Another thing that I talked about in the beginning was the reliability of the instrument. So this is short-term repeatability, and this is 500 readings in an interval of 1 second. And the data is very, very close to each other, so we know we're having a good repeatability. We also did long-term repeatability. This was 500 readings at an interval of 60 seconds, and also the repeatability is really, really good. The other thing that's important is we know that all of you don't use the instruments in a lab. Some of you take them out either to like the plants or you use them outside, depending on what's going on. And so we wanted to make sure that it was stable over time. And this has to do with the LED technology that's in the Bic Mac. So if you wanted to take the instrument outside, now you don't have to recalibrate it to take the data. It's already calibrated for you. So one other thing to make sure that we have really good technical performance for this instrument and we can use digital standards, we have settings that give you sample curvature, flat, low curvature, medium curvature, high curvature. And you can, the 4 pins is for the flat curvature. So that means all 4 pins in the bottom of the instrument have to be pressed completely down. And we use this on like standards or incoming test panels. The low curvature for like a hood, it only has 3 pins that you need to press, and 1 pin or 3 pins that you have to press at 0.1 millimeters, and 1 pin you have to press at less than 0.3 millimeters. The medium curvature would be like for a bumper. This one is 3 pins at less than 0.3 millimeters and 1 pin at less than 0.9 millimeters. And then high curvature, which would be like for a mirror housing. Sometimes you have to use this setting on some of the new fenders that are coming out because they're a lot more curved than in the past where they were more flat. And this one, you have 3 pins at less than 0.6 millimeters and 1 pin is completely turned off. And these settings are important if you don't set them up correctly and you go out to measure and you don't have them set in your organizer, which I'll talk about in a little bit, correct, then won't be able to measure your parts and you'll have to come back in and reset your pins. So now we're going to talk about standards and organized workflow. So the first thing will be digital standards, and then we'll show you some stuff about standard management, and then the organizers, which actually tell you where to measure. So what do we want to do with digital standards? Well, we want to take all the standards that were made up for this color and we want to find the center point. So we measure everything and then we come up with the center point of that standard so that everyone's going to the same place. In standard management, this is where you create and distribute the digital standards. And you can put your defined tolerances, your equations, whatever you like. But still, we do have certified and working standards to do the visual evaluation. Here's kind of the general idea of what would be considered a display, a working standard, or a certified standard. For display, it's anything over 0.5 for metallic colors. For working standards, it's between 0.35 and 0.5. And for certified standards for metallics, it's 0.35, less than 0.35. So for solid colors, most of the OEMs only use the 45. And you can see the different numbers. I'm not going to read them to you for the solid colors. So here's what standard management looks like. On the left side, you can see it has different color families. So this is where you set up the different tolerancing or the different equations that you want to use for each color. And if you're in a color family, you have to make sure that everything in that color family is going to have the same equations and the same tolerancing. On the right side, this shows you how it looks for the sparkle and graininess. And like I told you when we were looking at the tolerances, that this one is set up for a 3:1. So this is where you would set up all of your different parameters for all your colors. You can set up pass-fail criteria. You can use customer-specific scales, and you can send and receive digital standards to the entire supply chain. So basically, you can import and export any standard out of here and then email it to someone else, and then they can import it into their smart chart so that everybody is using the same standard. And this is really important when you're doing digital standards, because everyone needs to be using exactly the same information. So why is digital standards so important? In the past, at a lot of different locations, people were using different standards. They'd either measure them themselves or they would measure them with different instruments. And so the data really wasn't giving them any consistency. So here you can see I could be one of the suppliers and have like two different plants, and we wouldn't even be measuring to the same digital standard. So on the right, this is when you use a digital standard, everyone's going to the same target. So it makes it a lot easier for people to figure out, what's going on and if someone's actually off color or if everybody's in the same place. And it gives you a good match to standard. So this is an example of an organizer. So you can standardize your measurement and what your actual sample names are. So at some of the OEMs, what they do is they make a list of all the different check zone names, and then they send that to all of their locations so that they are using exactly the same terminology, which makes it a lot easier if you want to compare data from plant 1 to plant 2. You can set where you want things to be measured, so each location, and you can also set up what we call panel match for the harmony points. And that's something that you set up in the organizer. If you can see that it's at the very bottom on the right side where you set up the panel match. Here's also where you set up your curvature. So on this example, it's high curvature and there's only one sample being taken per location. You can change that number to anything you like. And then again, you can do the panel match at the bottom. Now we can talk a little bit about the software. So this is what Smart Chart looks like when you open it. And some people will have more or less apps depending on what instruments they have. But in this case, we're going to talk just about Smart Process. So here's Smart Process. So you have standard management, which we talked about, the organizer, which we talked about, and then you have data analysis, instrument management, data transfer, and configuration. The majority of the time, you're just going to be using the data transfer and the data analysis tabs. The other tabs you don't use all the time. So one other thing when we were working with different OEMs was that they wanted to be able to communicate the data into their own specific corporate system. So with the Smart Chart, you can do an SQL, and that database can be directly communicated into your database that you want everything to go into. So like we have some customers that do their own corporate systems where they like things in a certain order and be able to do the things that they want, and maybe it is more like a format that's automatic than in Smart Chart where you have to kind of know what you're doing to go in to find it. The data can also be exported in XML file. It can be exported in a .csv file. So data share is something that a lot of OEMs are moving towards. This really does help when, well, especially like when people couldn't always get to the plants to look at the parts. So you can look at all the data in a data share format. This is the normal setup for data share between paint shops and fascias. So we all paint our parts, and then the fascia guys, even before they send the parts to the OEM, they can send the data so that if they'd made a change or if they just wanted to make sure that they're in the same position as they were the last time they shipped stuff in, then everyone can look at the same data. And this is something where you can export a mini data file and then email it to your customer or to your supplier, depending on which direction it's going. And then they can pull that data in and actually look at the data to their data before they even ship the parts. So this is an example of the data share. The fascia is the yellow and the fender is the blue. So in this case, on the 15 and the 25, we're probably going to have some harmony issues based off of the data. The other three angles look pretty good, but it's a quick way to look at whether or not you're going to have harmony on the vehicle. Now we're going to look at some data analysis and some trending on effect. So here's a test report. This is just the first graph that you can show, and it's for only one vehicle. The dots on the vehicle itself, there's one dot that's a big dot. In this example, it's green or yellow. And then there's right next to it, there's two dots. The two dots show you the color harmony. And the one dot says if you're matching your master. So on the left side, at the bottom, you can see where it's harmony data. This is another report that we have where you can take as many parts as you would like and you can put them on one graph. And each one of the different characters represents a different location on the vehicle. And this gives you either overall harmony or it can give you trends over time if you're doing more than one vehicle. And it can show you if your process is robust or if you're having variations over time. Another graph is this graph that shows each individual component. So delta E, delta L, delta A, delta B. And you can trend over the whole vehicle. Also in here, we have the batch panels. That's the blue line to make sure that that's trending the same as our vehicle or hasn't changed over time. So this is just a trend over time for harmony. So again, the fascia, well, in this case is yellow and the fender is blue. And if you see your data separating over time or coming closer together, that means you're either getting better or getting worse. And it's a really easy way just to look at it. And also we have these travel graphs, and I like these graphs a lot because they show you again, the left fascia is yellow and the left fender is blue. They show you how each part's traveling relative to each other and over time. So my first two lightness, darkness plots at the top will be looking pretty good on the vehicle. And when I get to the third case, I'm separating on the 15 and the 25, so that could be a problem when I'm looking at the vehicle or walking around the vehicle. My delta A looks pretty good on all my parts, and then when I get to my B value, I'm having some issues with sometimes being yellower on one part or bluer, and that's also going to show up on the vehicle when you're looking at it. This happens to be a white mica coat, which everyone knows that there's some problems with white mica coats and getting the yellow, blue correct. So the final part of doing a color program is you want to make sure that what you are measuring and what you are seeing is the same. So this is a bumper, and if I'm standing over here and the sun is in the location that it's at in the picture, I'm actually looking at the 25 or even the 45. So when you look at a vehicle, it's really important that you pay attention to where the sun is and where you're standing relative to the car. Here's another example. This is if I'm standing on one side and someone's standing on the other side. We're actually looking at two different angles. And one of us could say, oh, this is horrible. We don't like this position on this car. And the other person can think that it looks pretty good. And so you have two different opinions, and that's not going to help when you're trying to get color harmony. So again, if I'm on the left side, it's 110 degrees is actually what I'm looking at. And if I'm on the right side, I'm actually looking at the 15 degree, and those two are very different. So what's important when we're looking outside at color harmony, we have to remember that depending on where we are in the world or what time of year it is, you can be looking at different angles. We always talk about looking at colors from 10 to 2 p.m., which is good, but even that sometimes doesn't give you all the information. So if I'm in Munich on June 21st, 2021 at 12 p.m., I'm looking at an incident light of 61 degrees. So what does that mean? Oh, sorry. Then if I'm in Detroit, I'm looking at the same day, same time. I actually am looking at an incident angle of 70 degrees. And if I'm in Shanghai, same date, same time, I'm actually looking at 82 degrees incident. And if I'm in Cape Town, South Africa, I'm looking at an incident angle of 32 degrees, the same date and same time. So what does this mean? Oh, sorry. This means that this Munich guy is looking at the 75 degree angle. And if I'm in Shanghai, I'm looking at the 110 angle. And if I'm in Cape Town, I'm looking at the 45 angle. So if I'm in Cape Town, I can be looking at the vehicle, and according to the data and what I see visually, I think, okay, this car looks pretty good. If I'm in Munich, I'm not going to necessarily really like the car, but it's only going to be like a yellow. But if I'm in Shanghai, I'm looking at the 110 angle, and that angle is out for color, so I'm not going to like the vehicle there. So it's always important to know where the sun is and what you're looking at. So here's just an example of the different times of year and how that can affect what you see and what you're measuring. So in June, I'm looking at a viewing angle of 75 or 110. If I'm in September or March, I'm looking at a viewing angle of 45. And if I'm if it's December 21st, I'm looking at an angle of 45 or 75. So this becomes a problem when most of the evaluations of color are done in like June or July, where my viewing angle is different. And then when I do like my first launch, I could be looking at a totally different angle, and then even in December. So the same vehicle could get approved in July and then get rejected, say in September or December. So this is also important to remember. The other thing that I think people don't always take into account is your height. So if I'm standing next to someone who's tall compared to me, we're actually looking at two different angles. So we either have to go closer to the vehicle or farther away from the vehicle if I'm the taller person, so that we're looking at the same angle. A lot of times I'll like step on my toes and stand up and try to see the same angle that that person is looking at if we don't have the same opinion of the vehicle. This is an example, and we see this a lot on curved surfaces, where you're trying to see the harmony between a curved surface and a flat surface. So this one, you would have an angle of approximately 75 that you're looking at. And if my curved surface and I'm looking at a different angle on that curved surface, I could be closer to the 25-degree angle. The other thing that's important is when we look at the horizontal surfaces. So here, the sun's behind my head. So when I look at this hood, I'm seeing an angle of 75 to 110. If I'm with the sun in front of me, now I'm looking at the 15 or even the minus 15. So that very much affects like what you see visually. This is just a summary of the outdoor evaluation, the time of day, the location in the world, the season, the influence of the observer, the size of the person, the distance between the person and the vehicle. And then you have to make sure you're paying attention to the influence of the evaluation. Location, so vertical panels, horizontal panels, and how the mounted orientation of the add-on parts. So how do we make this corporate program a success? The key thing here is support, especially from us at BIC, because we want to make sure that everything is helping you and you're getting good information. And that is the end.
Especially when you're looking at the different illuminants or the different angles, it's that consistency is the key, and being having a repeatable process every single time, so that if you're changing operators out, you're not going to see variation in the color data if you have a standardized process. Is that correct?
Correct. The other thing that's important, and I didn't put a slide in here for this, but it's the orientation of the instrument.
Yeah.
You want to make sure the instrument is always measuring the same way. There's two LED lights that are green at the top of the instrument that you always want to be facing the same direction as the sun, because that's where the illumination in our instrument comes from.
Good point. Good
We
point.
had some instances where maybe first shift was doing it different than second shift, and then people were thinking their processes were out of control, and it was just the way they were measuring the technique.
Yeah. Yeah. Good. Well, if people have questions out there, please, jot them in the chat box in the bottom right-hand corner, and we'll get to them. Got one question here too. If using a 45-0 or a sphere spectro instead of a multi-angle, is there anything that need to be done different to implement a color program? Or is it pretty much the same process as what you outlined here?
It's always pretty much the same process. You're just going to use a different instrument.
Okay.
I can jump in. I can jump in on that, John, too.
Thanks, Greg.
The one thing that you would want to have in addition to having all the consistent color equations and consistent areas of measurement and things like that is that you would also want to add gloss as a parameter to track. So in the case of 45-0 instruments, they're including gloss in that overall measurement, and a sphere-based spectrophotometer usually is in the specular included mode, which ignores gloss. So you want to be able to measure gloss also, and that might tell you what could be leading to a visual mismatch. Fortunately, with all of the color instruments, the sphere and 45-0 instruments that we have, there is a built-in 60-degree gloss meter. So if that doesn't cover the whole range that you need to have, then you would need to use a gloss meter that would measure either 20 or 85.
Good. Sounds good. Another question here too. At our facility, we don't take parts outside to look at, but we look at them under a light booth. Are there any suggestions in comparing solid colors versus effect colors?
Craig and I were talking about this the other day. I mean, the most important thing is you want to make sure you look at all the angles and try to understand what angle you're actually looking at when you're in the light booth. But it's hard because I know sometimes your parts are kind of bigger than the light booth itself, so it's hard to get the angle correct.
Yeah.
So the key thing, I think, especially for effect colors in a light booth, is to have some way to consistently look at the same angle. So whether that's, marking the light booth where you want your eyes to be, relative to the entry point of that light booth, and then placing the sample in the same place every single time, at least you're going to get one angle that's consistent.
Mm-hmm.
The other thing to remember is if you're evaluating something in a light booth, you also want to be aware of how that part is going to end up in the whatever is being manufactured, whether it's a refrigerator or an appliance or a office furniture component or what have you, and then maybe evaluate also in product position. So what Ray does in this presentation, a real good job of knowing how your visual evaluation of automotive body versus parts can vary quite a bit. Know that it can also vary for products that are manufactured and put into different environments.
Good point. Got a question from Gary here. What is the purpose of the minus 15 degree angle? What should we be looking at when measuring the minus 15?
So the minus 15 was put in for effect pigments that change color. Like the old, what are they called, Greg?
Well, the extreme is the chromaflare, but a lot of pearls will shift hue. And so the minus 15 is a good quality control tool to understand if you're really having a color change from a material standpoint or if it's a process change.
And there's not many colors in automotive where they turn on the minus 15. There used to be a lot more, but recently it seems like they're going back to more standard pigmentation, so it's not as critical.
Does that help, Gary? Does that answer your question? Or it could be Jerry, I apologize. Okay, great, thank you. Other folks, we have some time left, so if you have any questions, we have some great color experts on the phone here. question to you, Greg and Ray, when, a company comes to you, whether they're automotive or industrial or something else, and they say, well, we got some parts and pieces of a color program, what advice would you give them? Where's the starting point? How should they, really start looking at a comprehensive color program? What are the first couple steps?
I mean, I think the first thing is to get your management on board, obviously. But then the second thing is to start like with some colors using a digital standard and then seeing how that works. And we can always help with what equation to use or what we think would be the best tolerancing for it. It depends on the color sometimes.
And another point to that is, having good open dialogue about where the current pain points are, and different programs, different companies approach things in different ways. So sometimes it's people want to go after the biggest pain point they have. They have this problem and they want to try to address that right away. Sometimes that's not possible. So you talk about the whole program and find out where you can start to implement different pieces of the program. And then a lot of times that gives you momentum, and you can take care of some small things first and show momentum and show change. And then maybe the big bite is a little bit easier to go after. But it just depends on the company. So we ask a lot of questions and have a lot of open dialogue.
Good. Well, what are the biggest, while folks are thinking of other questions to ask you too, what are the biggest challenges that you see in working with companies integrating a corporate program?
It's time consuming.
Yeah.
And you have to want to do it. And you have to understand what the digital data really means for you. A lot of companies start off with, like, they have some problem color that's been a problem and it's causing them to get parts rejected. So they might want to start on that color just to see how it goes. And usually there's a lot of, sorry, my throat's a little bad today. There's a lot of momentum behind that, because if you solve the biggest color problem that you have, then people start understanding what is going on. And like Greg said too, the communication thing is really big because you have to be talking to each other. And I mean, from like the automotive perspective, I know when we first started doing data share, originally the fascia people weren't quite sure about it, but once they started using it and they could really find ways to improve by sending the data to the plants, they could get their colors bought off faster. And some OEMs actually use it when they design in the beginning. If they are like designing a new plant and they're doing work with like one of the robotics companies to make sure that their harmony is going to be good, or their color specific, or even their color is going to be good when they put it on their line, so they don't have to do so many evaluations on the line and run a bunch of trials. So the color is already there and ready to go.
And John, that's a good question. Another thing that sometimes we overlook is these are usually want to go at things for a long-term solution. Yeah. So one thing you have to definitely plan for is turnover. So that's challenging for everybody these days. It's hard to find talent these days, and certainly in very specific niches. So plan for turnover, plan for a way to retrain somebody, and also plan for how to qualify people. If you have somebody who's doing critical color matching, visual color matching, or color evaluation, you might want to evaluate their ability to see color and how well they can see color. And there's a number of tests out there that not only test for color blindness, but test for color accuracy. And then the third thing is plan for certification of your instrumentation. So
Yeah.
once you get the program up and running, you got to maintain that instrumentation, and you should follow some type of certification protocol, whether it's recommended by an instrument manufacturer or something that you follow internally for your own ISO certification.
Yep. And just super high level on this, the whole point is to, get the color right on time, every time, reduce scrap and waste, efficiency on operators and, your staff, is that right? Is there anything I missed?
No, that's it. It's throughput.
Yeah, it is. Cool. But yeah, like you said, it just takes time and developing these processes in a standardized, repetitive manner, and, training how to hold the instrument every single time from, first shift to third shift, as operators and folks change out. So any final questions here, folks? Quiet group today. Give another minute here. But like I said, you'll receive the link to this recording in your email as soon as we conclude. Also, we have a whole program of webinars set throughout the year. Look for those invites to come. We're doing our office hours, which is a shortened, abbreviated presentation, usually 20-25 minutes, followed by more of an open dialogue. This is one I consider our 60 minutes presentation, which is a more in-depth program on a certain topic. So stay tuned for those invites coming out. Thank you, Greg. Thank you, Ray. Really appreciate the time and expertise going through this. Hope your throat feels better, Ray. And I gotta ask, was that your dog sleeping next to you? I heard her breathing.
I'm sorry, she wouldn't get up, and there was no way I could move away from the presentation to move her. So
yeah, no worries. It was fun. I was wondering. And John just asked a question here too. If you have any follow-up questions, you can simply hit reply to any of the automated marketing messages, or I can let me put my email in here too. There you go. There's me. Feel free to send me any questions you have as well, and I'll direct them to the experts, whether it be Greg, Ray, one of our other application specialists, or someone in your region. So with that, I think we'll end this. Thanks again, Ray. Thank you, Greg. Thank you everyone for attending, and hope you learned something. And we look forward to seeing you on a future Bitgardener web seminar. Thanks, and have a great rest of your day.
Thanks, everybody.
Take care.